Question 2. A boat has a speed of 1.5 meters per second in still water. It's used to cross a river 500 meters wide, along which there is a strong current of speed 0.9 meters per second. The boat is directed towards the opposite bank, but the water current carries it downstream. Calculate the boat's speed relative to the bank. So this picture depends largely on which way you imagine the river is flowing. So I'm going to imagine we're trying to get across the river in this direction and that the water is flowing in this direction. So when I come to draw my velocity vector diagram, again, I'm going to draw the vector addition diagram. So I've got two vectors to add, one of size 1.5 meters per second in this direction, and one of size 0.9 meters per second in this direction, giving me the resultant going in this direction, which is the thing I want to find, the boat's speed relative to the bank. So the size of this velocity v should be equal to square root of 1.5 squared plus 0.9 squared, which is 1.749. So we're going to write 1.7 meters per second. B, the distance the boat is carried downstream from its point of departure to its point of arrival on the opposite bank. So in this particular case, I think there's an argument that it's easier to get the time taken to cross first. But let's not do that. Let's think about how we can solve this particular problem. So in terms of displacements, we're going to get a similar triangle to the one that we had previously. The displacement across the river is 500 meters. It's a wide river, isn't it? 500 meters, it has to go across the river. And while it's going across the river, it will also drift down the river a distance d. But we can say that the ratio of the sides in this triangle above has to be the ratio of the sides of the triangle here as well. The displacements and the velocities have to be in proportion to one another. So I'm going to say that, d over 500 must have the same size as 0.9 over 1.5, which then just means I can calculate d as 500 times 0.9 over 1.5, giving me my distance down the bank of 900 meters. Last one, the time taken to cross. Well, in just the horizontal direction, the boat still travels a speed of 1.5 meters per second. The distance it's got to travel is 500 meters. I'm back up here in the question. So this should just be a case of speed is distance over the time. So s equals ut. There is no half at squared term. So t is equal to the displacement over the initial velocity. It's 500 divided by 1.5. Which is 330 seconds. If we write it to two significant figures, 330 is, we could also write 5.5 minutes.